Canny College is dedicated to empowering individuals to excel in their refrigeration and air conditioning mechanic trade through top-notch preparation courses for the 313A Red Seal Trade Licensing Exam. Our online course is comprehensive and designed to equip you with the skills, knowledge, and confidence needed to pass the demanding refrigeration and air conditioning mechanic trade license exam and earn your 313A certificate of qualification. We are your trusted pathway to success in the Canadian Red Seal Trades License Exam, a crucial milestone on your journey to a rewarding career in the skilled trades industry. Aspiring professionals seeking a Canadian Red Seal trade license can rely on our institution's expertise. Canny College offers comprehensive online exam preparation courses for various skilled trades. It uses an innovative learning approach and a commitment to excellence to equip students with the essential skills and expertise required to succeed in their chosen trades. Visit our website at www.cannycollege.com for more details. Please note that the practice questions provided here demonstrate the structure and phrasing of Red Seal examination questions. They are for study purposes only and do not result in certification or reflect actual performance on the examination. Question 1. When constructing a walk-in freezer box, where is the vapor barrier installed? A. Under the floor slab. B. Inside, on the coldest side. C. Outside, on the warmest side. D. Around any penetration sleeves. The correct answer is C. Outside, on the warmest side. Here are 4 reasons. 1. The vapor barrier is typically installed on the warmest side of the insulation in a walk-in freezer box to prevent moisture from entering the insulation and causing issues such as condensation, mold growth, and reduced insulation effectiveness. Placing the vapor barrier on the warmest side helps to keep the insulation dry and maintain its thermal resistance. 2. Placing the vapor barrier on the inside, on the coldest side, could lead to condensation forming on the barrier itself, which can compromise its effectiveness and lead to moisture-related problems within the insulation in the freezer box. 3. Installing the vapor barrier on the outside, on the warmest side, helps to minimize the risk of moisture infiltration from the exterior into the insulation. This helps preserve the integrity and performance of the insulation over time. 4. Additionally, placing the vapor barrier on the outside makes it easier to access and inspect for any damage or issues that may arise. This can facilitate maintenance and repairs as needed to ensure the proper functioning of the walk-in freezer box. Question 2. There is high suction pressure on a heat pump. What is the cause? A. Low refrigerant charge. B. Leaking reversing valve. C. Leaking liquid line solenoid. D. Restricted liquid line filter dryer. The correct answer is B. Leaking reversing valve. Here are 4 reasons. 1. A leaking reversing valve can cause high suction pressure in a heat pump system. The reversing valve switches the direction of refrigerant flow between heating and cooling modes. A leak in the valve can disrupt the normal refrigerant flow, leading to imbalanced pressures. 2. When the reversing valve is leaking, the refrigerant may bypass the intended route, resulting in higher suction pressure. This can impact the heat pump's efficiency and ability to transfer heat effectively. 3. High suction pressure due to a leaking reversing valve can also affect the system's overall performance, causing issues such as reduced heating or cooling capacity, increased energy consumption, and potential damage to other components. 4. Inspecting and addressing a leaking reversing valve promptly is essential to maintain the heat pump's optimal operation and efficiency. Repairing or replacing the valve can help restore proper refrigerant flow and pressure balance within the system. Question 3. The enthalpy control on a rooftop air conditioning unit's economizer is being calibrated. Which instruments are selected? A. Manometer, ammeter, and psychrometer. B. Manometer, pitted tube and thermometer. C. Multimeter, pitted tube, and thermometer. D. Thermometer, psychrometer, and multimeter. The correct answer is D. Thermometer, psychrometer, and multimeter. Here are 4 reasons. 1. Thermometer. A thermometer is essential for measuring the temperature of the air entering and leaving the economizer to determine the temperature differential and effectiveness of the cooling process. 2. Psychrometer. A psychrometer, which consists of a dry bulb and wet bulb thermometer, is used to measure the relative humidity of the air. This helps in assessing the moisture content in the air and determining the enthalpy levels for proper calibration of the economizer. 3. Multimeter. A multimeter is used to check and measure various electrical parameters such as voltage, current, and resistance. In the case of calibrating the enthalpy control, the multimeter may be needed to ensure the electrical components and sensors are functioning correctly. 4. These instruments, thermometer, psychrometer, and multimeter, provide comprehensive data on temperature, humidity, and electrical parameters necessary for calibrating the enthalpy control on the rooftop air conditioning unit's economizer. They enable accurate adjustment and optimization of the economizer's operation for efficient energy utilization. Question 4. Which cooling coil is selected for maximum dehumidification? A 4-row high velocity, B 4-row low velocity, C 8-row low velocity, D 8-row high velocity. The correct answer is C 8-row low velocity. Here are 4 reasons. 1. An 8-row low velocity cooling coil is selected for maximum dehumidification because the increased surface area provided by the additional rows allows for more contact between the air and the coil. This extended contact time enhances the coil's ability to extract moisture from the air, leading to improved dehumidification performance. 2. Low-velocity coils are designed to operate at slower airspeeds, allowing for a longer contact time between the air and the coil surface. This prolonged contact time increases the coil's efficiency in removing moisture from the air, making it suitable for applications where maximum dehumidification is desired. 3. A higher number of rows in the cooling coil increases the heat transfer capacity and provides more surface area for moisture removal. The 8-row configuration enhances the coil's dehumidification capacity, making it an ideal choice for applications requiring effective moisture control. 4. Selecting an 8-row low-velocity cooling coil ensures that the air passing through the coil is sufficiently dehumidified, contributing to improved indoor air quality, comfort, and humidity control in various HVAC systems. The combination of increased surface area, prolonged contact time, and low air velocity enhances the coil's dehumidification performance. Question 5. Which type of oil is the most hygroscopic? A. Naphtha, B. Mineral oil, MO, C. Alkyl benzene, AB, D. Polyester oil, PO. The correct answer is D. Polyester oil, PO. Here are 4 reasons. 1. Polyester oil, PO, is known to be the most hygroscopic among the options listed. Hygroscopicity refers to the ability of a substance to attract and retain moisture from the surrounding environment. PO oils have a stronger affinity for water molecules compared to other oil types. 2. The high hygroscopic nature of PO oil makes it effective in trapping and absorbing moisture present in the system. This quality can help prevent water accumulation that may lead to issues such as corrosion, oxidation, and reduced system efficiency. 3. Compared to mineral oil, MO, alkyl benzene, AB, and naphtha, PO oil is more prone to moisture absorption, which can be beneficial in systems where moisture removal is critical to ensure optimal performance and equipment longevity. 4. Due to its hygroscopic properties, polyester oil, PO, is commonly used in refrigeration and air conditioning systems where moisture control is essential to maintain system reliability and efficiency. Selecting PO oil can help mitigate potential moisture-related problems and ensure proper system operation. Question 6. Which terminal controls the reversing valve on a heat pump? A. L. A. B. O. B. C. W. D. Y. The correct answer is B. O. B. Here are 4 reasons. 1. The O. B terminal on a heat pump thermostat controls the reversing valve, which is responsible for changing the direction of the refrigerant flow to switch the heat pump between heating and cooling modes. The O. B terminal activates the valve to determine whether the unit operates in heating, O, or cooling, B, mode. 2. When the thermostat calls for cooling, the O. B terminal signals the system to activate the reversing valve, allowing the refrigerant flow to reverse and provide cooling. When the thermostat calls for heating, the O. B terminal reverses the valve back to its original position to provide heating. 3. The O. B terminal is specific to heat pump systems and is critical for proper operation, as it controls the mode of operation and ensures that the heat pump functions correctly for both heating and cooling cycles. Incorrect wiring or malfunction of the O. B terminal can lead to issues with the heat pump's performance. 4. Understanding and correctly utilizing the O. B terminal on the thermostat is essential for homeowners and HVAC technicians to ensure that the heat pump's reversing valve functions as intended, enabling efficient and effective operation throughout the heating and cooling seasons. Question 7. A manual pump down is required. How is the king valve adjusted? A. Turn the stem clockwise to the front seat. B. Turn the stem clockwise to the back seat. C. Turn the stem counterclockwise to the front seat. D. Turn the stem counterclockwise to the back seat. The correct answer is A. Turn the stem clockwise to the front seat. Here are 4 reasons. 1. When performing a manual pump down procedure, the king valve needs to be adjusted to stop the flow of refrigerant to the system. Turning the stem of the king valve clockwise to the front seat position will close off the valve completely, preventing any refrigerant flow through the system. 2. The front seat of the valve refers to the fully closed position where the valve is fully seated, blocking the flow of refrigerant. Turning the stem of the king valve clockwise to the front seat ensures a tight seal and effectively shuts off the refrigerant flow. 3. By front seating the king valve, the refrigerant can be contained within the system and prevent any leakage during maintenance or service procedures. This is essential to safely and effectively carry out tasks such as repairs, system checks, or component replacements. 4. Properly adjusting the king valve by turning the stem clockwise to the front seat position plays a crucial role in performing a manual pump down procedure accurately and securely, allowing for the safe removal of refrigerant from the system. It is a fundamental step in maintaining the integrity of the system and ensuring proper refrigerant management.